Hey guys, so there's been some questions about balancing the equations. So I'm going to start with a couple of these, and I'm going to have to flip the camera around if it's going to print right side up or not. Let me turn around. Get all the cords situated. And let me go make this full screen. H2 plus Br2 yields HBr. Okay, so when we balance equations, we want to have the same number and kinds of atoms to the left of the arrow as we do to the right of the arrow. And it doesn't matter what combination they're in. They can be in different combinations in the side of the arrow, but you have to have the same numbers and kinds. So we have hydrogen atoms and we have bromine atoms. We have hydrogen atoms over here and we have bromine atoms over here. So we have the same kinds of atoms on both sides. Now we need to start counting the atoms. The two behind here means that you have two hydrogen hooked together. So right now you have a total of two hydrogen. The two down here means that these are two bromine atoms linked together. So you have two bromine atoms. But over here, there's no subscript, there's no coefficient. So if there's not one there, it's understood to be 1. So when a chemical equation is balanced, you have the same number of atoms and kinds on either side of the arrow. All right, so you start with this. A certain amount of atoms here, and after the reaction, they can be rearranged, but you don't lose atoms, and that's that law of conservation of mass and energy. All right, so the formulas or the equations I'm going to give you, the formulas are written correctly for you. So in a college chemistry class or like in a high school chemistry class, they might give you a word equation like hydrogen written out, something like hydrogen I spelled that wrong. That's really bad. Hydrogen plus oxygen yields water. Now, they might give you something like that, and you would have to know that hydrogen, when hydrogen atoms are by themselves, they're always diatomic, which means there's always two of them. Oxygen, when it's by itself, it's always diatomic. There's two of them, and you'd have to know the formula for water. And once the formulas are written correctly, you would balance the equation by putting the coefficients out in front. So the equations I'm going to give you, the formulas are already written correctly. And to balance it, you have to put numbers in front. And remember, when you put the numbers in front, it doubles everything behind it. So if I need two hydrogen over here, the only place I can put a 2 is right there. And when I put a 2 here, it now means that I have 2 molecules of those, which means I have 1, 2 hydrogen, and I have 1, 2 bromine. When we get into the polyatomic ions with the parentheses, another way to do this instead of drawing all these out and counting them is you take the coefficient behind the subscript. So 2 times 1 would give you 2. 2 times the 1 here would give you 2. So you have 2 hydrogen, 2 hydrogen, 2 bromine, 2 bromine, and that one's balanced. Okay, so let me make this smaller, and let's look at another equation here. Okay, let's do this one before we go to a polyatomic ion. So we have KNO3, and after the reaction, it's going to break down into 2 simpler substances. This is called a decomposition reaction. plus O2. So we're going to have to count everything. So we have 1, 2, 3 atoms here. 1, 2, 3 types of atoms here. So I have, put my arrow right there. I've got potassium, I have nitrogen, and I have oxygen. And over here, I have potassium, I have nitrogen, and I have oxygen. Now, let me say this. I would write these elements in the same order going down because it's less confusing. It's easier to keep up with them. Now we have to go back and count the atoms. No coefficient here, so that means it's understood to be 1. So we have 1 potassium, we have 1 nitrogen, but because there's a 3 there, that 3 goes with the oxygen. So we have 3 oxygen atoms. Now we're going to come over here to this side of the arrow. We're going to start counting atoms over here. No coefficient, so it's understood to be 1. I have 1 potassium, I have 1 nitrogen, but I have a 2 here and a 2 here. So now I have 4 oxygen. Oh, let me go back. I need to enlarge this. Sorry. So let me go back. So I went through and I wrote my potassium, my nitrogen, and my oxygen down. And I wrote them down in the same order so it's easier to follow. Then I went through and counted my atoms. No coefficient here. It's understood to be a 1. Okay, if there's no coefficients, it's understood to be a 1. So I'm going to kind of pencil, politely put that in. So to count the atoms, you could say 1 times 1 is 1, 1 potassium. 1 times 1 is 1, 1 nitrogen. 1 times 3 is 3 oxygen. You know, if it helps you to have a 1 there, that's fine. If not, you just simply go, there's 1 potassium, 1 nitrogen, 3 oxygen. When I get over here, no coefficient, so everything back here is understood to be what it is. 1 potassium, 1 nitrogen, 2 oxygen here, 2 oxygen there. That's a total of 4 oxygen. Now, let me say something. When you have these odd numbers here, like a 3 and a 4, I would try to find like the least common multiple. What's a number that they both will go into? Because then it's easier to figure out the rest of it. So the smallest number, if I double 4, that's 8. 3 will not go into 8 evenly. 3 times 4 is 12. 4 goes into 12 evenly, and 3 goes into 12 evenly also. So that would be 4. So we need to figure out a way to get 12 oxygen. Now, that's one way to do it. So to get 12 oxygen, I'm going to have to put a 4 right there, a 4. And when I put a 4 there, that means it quadruples all of this. 4 times 1 becomes 4. 4 times 1, I have 4 nitrogen now. And now I have 12 oxygen. So if I have 4 potassium here, I need to get 4 on this side of the arrow. So the only way to do that is to put a 4 there. 4 times 1 would give me my 4. 4 times 1 here would give me 4. And 4 times 2 gives me 8 plus 2 more is 10. That's not enough. But I don't need to put a 5 here because that throws all this mess off. But I can still put a number there. So 4 times 2 is 8. I'm looking for 12. If I subtract 8, if I put a 4 there, that gives me 8 there. I need 4 more. So to get 4 more, I can put a 2 here. Now, what I'm seeing here is I have a 4, 4, and 2. That's not the lowest common multiple, okay? Actually, what you could do is you could reduce these coefficients down by 2. So you could have a 2, you divide everything by 2, that gives you 1. So 2 times 3 is going to give me 6. So if you did 4, 4, and 2, it'd be balanced. That probably makes more sense to find the lowest common multiple for the oxygen. I would not mark this wrong. But to have a lowest ratio, when you have numbers like this, you can divide them and get a simpler ratio of elements. Okay. All right, let me make this smaller. And let's go up here to this lovely, pretty one. The first one I hit you with. You probably went, what the heck is that? All right. So when this equation is balanced, the coefficient in front of H3PO4 is. So what this looks like, let me write it down, then I'll make it larger for you to see, because I need to see the original one. CaNO3, that big 2 should be a subscript 2. Put a line in front, so I know I'm going to have to put a coefficient. H3PO4 yields Ca3PO4 plus HNO3. And that's a lovely one. Okay, so here's our arrow. Now, they said what's going to be here when it's balanced. Now, let me start out by showing you how to count these atoms. When there's a 2 behind the parentheses, that means everything in here gets doubled. Not that one, just the one in the parentheses. And you could double it and write NO3 twice and count your 2 nitrogen and 6 oxygen, or you can multiply. Okay, so I'm going to start with calcium here. I'm going to write Ca. There's not a coefficient. It's understood to be a 1, so right now I have one of those. This 2 back here means I'm going to double everything inside the parentheses. So 2 times 1 for nitrogen means I have 2 nitrogen, no nitrogen over here. So all I have is 2 to the left of the arrow. And 3 times 2 gives me 6 oxygen, but I also have 4 over here. So 6, 2 times 3 is 6, plus 4 more gives me 10 oxygen atoms. And when I go here, I have another element. I have hydrogen. I have 3 of those. The P stands for phosphorus, and I have 1 of those. So now I have to come over here and start counting what's on the right side of the arrow. This 3 right here goes with the calcium. That means I have 3 calcium, which I'm like, there's part of the problem. The PO4 is in parentheses, so that means I double everything inside. So that's understood to be a 1. So 2 times 1 is 2. And I'm going to write that down here across from the other P so I can look at them a little bit better. So that's 2 phosphorus. And then I have 2 times 4 is 8, plus 3 more. That's going to give me 11 oxygen. That's going to be lovely. And hydrogen, I just have 1. And nitrogen, I just have 1. Okay. So, what I would do is I would start with a 3 over here and just kind of go through it mentally. If I put a 3 here, that means I got 3 calcium, and boom, that's taken care of. 2 times 1 is 2, but then I have a 3 out here, which means I'm going to have to do 3 of those. So 3 times 2 is going to give me 6 nitrogen. That means I have to put a 6 there. And then a 3 out here. 2 times 3 is 6, times another 3 would give me 18 oxygen. So let's just start playing with this. And a lot of times it is just trial and error. and they didn't give you any clues in the problem. So I'm going to start with a 3 here. So when you have a coefficient, everything behind it gets multiplied. So 3 times 1 is going to give me 3. And there's a 1 here. So 2 times 1 is 2, but I have 3 of them. So 2 times 3 gives me 6 nitrogen. And 2 times 3 is 6 here, but I have 3 of these. So 2 times 3 is 6, times 3 is, that's going to change my oxygen to 18. Okay. All right. Now, I'm going to stop here for just a moment. I know my hydrogen and my phosphorus is off. So let me start with a 3. Let me get this to a 3 and see what happens to everything else. If I put a 3 here, that means everything back here gets tripled. 3 times 1 is 3 hydrogen. 3 times 1 here is 3 nitrogen, so that's automatically not enough, okay? And 3 times 3 oxygen is 9, plus 8 is 17, but I don't have enough nitrogen. So what I'm going to do is I'm going to jump out here, and I'm going to go from a 3, and I'm going to change this to a, I leave it a 3, that means I have 3 nitrogen. So let me change this to a 6. 6 times 1 is 6 hydrogen. 6 times 1 is going to give me my 6 nitrogen. 6 times 3 is 18, plus 8 more is going to give me 26 oxygen, okay? All right. So I'm up to 6 hydrogen. I have 2 there. So let me try 3 here. So 2 times 3 is going to give me 6 hydrogen. And 2 times 1 is going to give me 2 phosphate. And 2 times 4 is going to give me 8. And remember, I had 2 times 3 is 6. Times 3 is 18. So that was 18 oxygen over here and 8 oxygen there. That gives me 26 oxygen. 3, 6, 26, 6, 2. Okay, that's balanced. And the question was, what's the coefficient in front of phosphoric acid? And that would be a 2. So let me go here. And let me go do this. I have to think for a moment. The coefficient in front of H3PO4 is 2. Okay. That's how you process these equations. That's an easy one. We've done that one. So I'm going to stop here, and I'm going to post this, and we'll see how y'all are doing.